The first problem here is a plus b when a is 4 and b is 5, so we just put them in. Input the values. So in place of a we put the value 4, and in place of the b we put the value 5. And 4 and 5 is 9. Here we're told that x is 2, and we've got x squared, that's 2 squared, plus 3 lots of x, that's 3 lots of 2, put it in a little bracket if we want, and then plus 7. So we've got 4, 6, and 7. 6 and 7 is 13, and 4 is 17. Here 6a, a is 4, so that's 6 fours. Minus 4 times b, 4 lots of b, b is 5. So we've got 24 minus 20. 24 minus 20 is 4. C, minus 4 cubed, so that's minus 4, that object cubed, put it in a bracket so it's unambiguous, and x is 2. So we've got minus 4 times a minus, basically, which comes out as a minus, doesn't it? And then we've got 4, the 4 times the 4 times the 4, which is 64. Over the 2, cancel 2 top and bottom, we get minus 32. I'll just leave it there, because there's not much room. Minus 32. This one here, 4 lots of minus 3 times x, x is 2. So that's 4 lots of minus 6. 4 6s are 24. Plus times a minus, because 4 on its own means plus 4. So it's plus times a minus is a minus. 4 6s are 24. Okay, x is 2 here, so put 2 in. We get 10, 2 plus 8 is 10 on top, and 2 plus 3 underneath is 5. 10 over 5 is 2. You could cancel by 5 top and bottom if you wanted. 2y cubed, y is 3, so 2 3's, basically, 2y cubed. 6 cubed, which is, tap it in the calculator if you need to, 216. It's actually 6 lots of 36. And you can see that 6 30s are 180, and the 6 6s are 36. When you add them up, you get 210, 216. So you can do it in your mind's eye sometimes, or you can tap it in the calculator. Okay, now simplifying expressions now. Let's have a look at these as examples. Well, you've got an a, you've got another 2a, and you've got another 3a all added together. An a on its own really means 1a. It's like an x. What we mean is we mean one lot of an x. And similarly, if you have a minus x, what you really mean, or minus an a, what you actually mean is you mean minus one lot of x. That's what you mean. And minus one lot of a. And the same goes with the number 5. If you want to, sometimes you can put, well, that's just one lot of 5, if you want to, if it's convenient for algebraic purposes. Okay, so now that's clear, we've got one lot of a then, here, plus another 2, plus 3, that makes 6 lots of a, doesn't it? Here, how many b's have we got? 3 and 2, we've got 5b. And we got 1c, take away 4c is minus 3 lots of c. Here we've got 6x minus 2x. 6 take 2 is 4, so that's 4 lots of x. Take another x is 3x. That's the number of x's dealt with. And it just leaves the plus 12 minus 4. 12 take 4 is 8. So we end up with 3x plus 8. Here, the x squareds. We've got 3 there, we've got 1 more there. So that's 4x squareds. That's that one. Oh, sorry, that one and that one. Now the x's, we've got 4x take 2x. So 4 take 2 is 2, so there's 2 lots of x then. And now lastly we've got the numbers 5 and 1. 5 plus 1 is 6. So we've collected the like terms, haven't we, there, and simplified the expression. Okay, here xy, and we've got x squared y, and then we've got xy squareds, and we've got an x squareds, and we've got a y squareds. Have we got any other xy's in all this line? No. So it's just xy. X squared y's, have we got any other x squared y's in this line? No. So just plus one of those. X squared y. Have we got any more xy squareds along here? Xy squareds? No. So it's just minus plus xy squareds. And then have we got any more x squareds Well, not on as a number. We've got y lots of x squared, so we could put them together. But really, we haven't got any other numerical x squareds, have we? So we could just tidy it up like that. And similarly, y squareds. I know we've got x, y squareds here, so you could collect them. But we haven't got another number of y squareds, have we, in this line? So we can just put minus y squareds. So there's no real simplification per se, as far as the numerical quantities are concerned. Nothing more to do there, just leave that as is. Now when you're expanding brackets now, let's have a look at that example. Basically you've got two 7s, haven't you? Two lots of 7. Work out the number in the bracket, and that's 14. Now I've drawn two lines to show you that you can also do it using draw two lines, line 1 and line 2. The first line is two 4s, so that'll be two lots of 4. And the next line will be two lots of 3, see it? Plus two lots of 3. So that's two 4s are 8, two 3s are 6, 8 and 6 is 14. So this is the method that's generally used for expanding brackets. We draw two lines when it's in this form. So here we can just draw two lines, lines 1 and lines 2. First line, 2x. Second line, 2y. Okay, next one. So first line, 4x squareds. Next line, 4 lots of 2 is 8, 8x's. And the third line, 4 3s are 12. Okay, that's good. Now the next one. So two lines again. It's this form, isn't it? So the first one is 7x plus, and then we've got the second line, 7 2s are 14. Next one, minus 2. Draw two lines, is outside the bracket. So minus 2 times 3 is minus 6, lots of x. And the next line, minus times a minus is a plus. 2 times y is 2y, plus 2y then. Next one, again it's just two lines, always the same. 2a times another a is two lots of a times a. And we usually write a squareds, don't we, for that? And then the next line, 2 times 3 times a times b. 2 3s are 6. And you've got times a times a b is 6ab. So that's that one. Next one. Now we've got a minus this whole bracket here. Now this is a similar in form to all the problems that we had before. It's just not obvious. When we have minus something, remember we said we have minus a. What we said was we have minus one lot of a, don't we? So for the purposes of expanding the bracket, it's convenient to put in that number, minus one lot of this bracket. Now we can draw two lines clearly. Minus one lot of 2x is minus 2x, isn't it? And then minus times a minus is a plus, and one lot of 4y. Okay, good. Here, the number's just on this side rather than on this side, but the same process applies. You just draw two lines. Lines 1 and lines 2. So you could, it doesn't matter which order you write them in. So you could write line 2 first and then line 1. Or you could write line 1 first and then line 2. I'm going to write line 1 first because it's positive. Minus times a minus is a plus, 3 4s are 12. And line 2, we've got minus 3x. That looks easier on the eye than writing minus 3x plus 12. Prefer this. And it looks a bit scruffy, but most people prefer that as being easier on the eye than this thing. They're both the same, and they've both been marked correct. Next one. Well, here you've got one term outside, here one object, and you've got three things inside, so you follow the same principle, but instead of drawing two lines, you draw three. 1, 2, 3. So your first line, 2x times x squared. That 2 is not, that's for the line. So it's 2x times x squared will be 2 lots of x cubed, wouldn't it? Next line, 2 times 5 with a minus is minus 10, times x is x squared. And then the last line, 2 3s are 6 times the x plus. Okay, good. Now we come on to, so that's that type with one term outside the bracket. You draw either two lines or three lines or however many you need. For these ones, let's see how the rule applies here then, shall we? This is 6, isn't it? And this bracket is 8, so this is 6 eighths, so that should equal 48. So we're going to write down the rule straight away. 2 lines for the first, 2 lines for the second. This is line 1, 2, 3 and 4. And hopefully we'll get 48 using this rule. So let's see if we do. 2 3s, 6, and then 2 5s, line 2 is 10. And then 4 3s are 12, and 4 5s, line 4 is 20. So what do we get? 16, 18, 28, 38, 48, 48. That's it, which is what we wanted. So this is the rule we use for expanding brackets when we have 2 terms in one bracket and followed by another 2 terms in the second bracket. We draw 4 lines. We draw 4 lines, 2 for the first and 2 for the second. Lines 1, 2, 3 and 4. First line, x times x is x squared. Second line, 2x. Third line, 1x. And then the fourth line, 1 times 2 is 2. So we get x squared plus 2x and x is 3x plus 2. So that's what we get for that one. Here, the same principle applies. 2 lines for the first and 2 lines for the second. So the first line, 2a times 3a is 2 3s is 6 times a times a, 6a squared. Lines 2 is, that was 1, this is 2, this is 3, this is 4. 2a times 4b, 2 4s are 8. And then we've got the a times the b, haven't we? ab, 8 lots of ab. Then we've got 3a times b, see it? Which we can write as 3ab. So plus 3ab for line 3. I've written it as ab because it's easier on the eye. It's just a product. And then line 4, 4b times another b is 4b squared. So we can tidy this up now. We've got 6a squared. We've got 8ab and another 3ab is 11ab plus the 4b squared. Okay, good. So let's do a couple more if we get time. I'll look at that one in a moment. I'm just going to do this one, I think. Pull this down here. And we've also got this one here to do. So let's have a look at these. So this is something squared, 3c plus 2 squared, which you can write as 3c plus 2 times 3c plus 2. Now we can draw our 4 lines, because that's what the something squared means. 1, 2, 3, 4. So the first one, 3 times 3 is 9c squared. Second one, 2 times 3c is 6c. Third one, 2 times 3c, another 6c. And then the last line, 2 times 2 is 4. So that's equal to 9c squared plus 12c plus 4. This one is a plus b times a plus b. 2 lines for the first, 2 for the second. A squared, the first one, plus an ab, plus a ba, which we can write as ab, plus a b squared, isn't it, the last line. So we end up with a squared plus 2ab plus b squared. And now the last one, which is customarily called the difference between two squares, is called that because with this pattern, it just so happens that the middle terms cancel each other out. So let's have a look at that. A squared. Then we get minus ab for the second. The third, plus ab. And then the last, b times b is b squared with a minus. Plus times a minus is a minus. So can you see how that, ab take away an ab will just disappear and we're left with a squared minus b squared, which is called the difference between two squareds. So that's a standard identity. And it's something that's used a lot, a plus b times a minus b. In maths you see it all the time, and sometimes it's convenient to write either this or this, whichever's most convenient.